talk focuses on energy and the changing energy environment, not just from individual building perspectives, but in the context of our significant commitment to achieve overall carbon zero emissions for Aotearoa within the next 30 years. So I'm going to introduce and explain the concept of smart electricity grids, and then extend these ideas to their community and housing impacts, but not losing sight of the bigger picture. We're all in this together. The electricity grid that we have, and that's been around for 100 years or more, we can describe as the legacy grid. Now, it's worked well, but it is monolithic and hierarchical, and it's dominated by the need to always be generating just as much electricity as is needed at that point in time. Now, this is actually a challenge for the new renewable sources like solar and wind, because they don't respond to our commands, but to the weather. One of Transpower's earlier analyses of the legacy grid, they pointed out that this need for balance drives much of the complexity, the risk, the cost in modern power systems. And this is really a major point in my presentation. Now, the other characteristics of this legacy grid, that the significant loads tend to be in the big cities and around the major industries, as we can see on this map with the blue circles. And the major generation sources tend to be on the big rivers, on windy ridges, or near coal mines or geothermal fields. So the grey circles on this map, if you can see it. And these electricity sources are usually well away from the major loads. So we have this electricity grid, which is a major infrastructure, and its role really is to make sure the energy gets from the source where we generate it to the loads. And as I say, they tend to be different and in different places. Now, the one-way power flow that we get with this traditional electricity grid is not actually very well suited to accommodating the sorts of distributed generation sources which are increasingly common and can provide a sensible solution to our growing energy demands. Things like rooftop solar and that Tesla Powerwall on the side of your garage. So what comes next is what we call the smart grid. Well, we've got to achieve zero carbon, certainly within the next 30 years. And currently, electricity provides about a third of the energy that we use, with the rest almost totally carbon-based. So although people talk about other contenders, things like hydrogen and other things, electricity is our most readily available form of renewable energy. So we need to grow our electricity generation enormously in the next few years, looking to significantly remedy that 2/3 of the dirty energy which we currently use mainly for industry and transport. But at the same time, we need to strive for greater efficiency in the ways that we use electricity, potentially reducing that final goal. And so what we can do, for example, with housing in terms of using energy more efficiently can in fact help us reduce that need. But these 2 points are really driving most of this move to the smart grid, and really that's the need to grow our electricity generation and to strive for greater efficiency. And that's really mostly what I'm going to be talking about. Now, there are important changes in the way that we perceive and manage the electricity grid. The fact that many of the new sources of electricity tend to lend themselves to distributed location nearer the demand, things like solar, for example. That can reduce the need for massive growth in the grid infrastructure because we don't have to move energy around quite so much. But the fact that most of these sources are what we call non-deterministic, the fact that we can't turn them on and off on demand, we can't tell the wind to blow, we can't tell the sun to shine, we just have to hope it does. One or other of them does. This means that we need to include storage in our grid, but we can exploit that storage if we plan it well to further reduce the need to grow our transmission capacity. Now, just to demonstrate that point, let's just take a quick look at a domestic solar situation. The panels generate electricity during the daylight hours, but the household load doesn't match this at all well, with peaks at breakfast time as you can see, and in the evenings. Now, if we don't have a battery, then that excess that we produce in the middle of the day, we probably want to try and sell back to the grid. And that extra energy that we're going to need at night time, we want to buy back from the grid. Unfortunately, most of the energy companies aren't particularly interested in buying your excess, and at best will offer you about a third of the price that you pay for the energy from them. So in fact, we're far better off to have our own battery to carry the excess from the day and allow us to use it at night time. Now, if we have a big enough battery, then we could probably manage to have an almost constant but quite small load on the grid for the entire 24 hours. And of course, if we manage to make our load relatively constant, then this does have quite big implications as far as the grid itself is concerned. It doesn't necessarily have to carry such big loads. Now, Transpower have produced a list of 10 technologies they believe will disrupt ships, electrification of the transport industry. And of course, the third technology that Transpower have listed here is the autonomous vehicle technology, driverless cars, because they have the potential to change our car ownership patterns, reduce the total number of vehicles that we have because we could share them more, and alter many of the aspects of the way in which we live, particularly in New Zealand, which has one of the highest personal car ownership levels in the world. Then there are a group of technologies which are concerned with the generation and storage of electricity. First of all, rooftop solar and household batteries, obviously becoming increasingly common. Then we've got the idea of community or utility level solar and wind farms. We see a lot of wind farms around now, but not at this stage so many solar installations in New Zealand that aren't just rooftop solar. And then, of course, there's the grid-scale storage systems. And although, we're not seeing a lot of these in New Zealand at the moment, they are being pursued in a very big way in Australia at the present time. And then there's another group of technologies which are changing the business and economic models that we see in the electricity industry. First of all is the digital innovations, particularly relevant for smart home management. Right, things like the Internet of Things and devices which can be interconnected, if you like. And then there are the changing business models of the smart grid, which we need to make sure are leading to an overall better world rather than just greater riches for some. And then the third one of that group is, in fact, the continuing pursuit of automation, particularly with the way in which it can potentially change our work patterns and the ways that we work. And then finally, amongst this list of 10, Transpower have listed the transformative technologies still to come. Hydrogen, perhaps, new storage technologies. There's growing interest in tidal and wave generation. Well, most of these technologies are still really speculative and have got a way to go, whereas most of the others that we've talked about are all here now and ready for us to make use of. So where is the grid, or the smart grid, taking us? It's taking us to a more integrated grid. It's less hierarchical, less monolithic, and one that supports smart, innovative technologies. One that makes exclusive use of renewable energy. That is important because, remember, this zero carbon goal. One that enables and supports bidirectional transmission. By that we mean we can move energy in any direction so that industry could make better use of that surplus from your rooftop solar. One that positively encourages distributed generation and storage, what I describe as the local consumption of local generation. And that can have a big impact on the need or can reduce the need for growing the grid infrastructure. It also needs to fit with the huge growth we expect to see in our electricity demand, remembering that electricity at the moment provides only about a third of our energy needs. And also, it needs to support the sensible planning of infrastructure, things like neighbourhood microgrids, where we can share locally the local production, locally consume the locally produced energy. So There are some key technologies that the smart grid incorporates, if you like. Renewable generation, more wind, more solar, maybe some microhydro, maybe wave, tidal, these sorts of things. Secure and ubiquitous communication is an important part of the smart grid, and there are some concerns that using the internet, for example, to have control information about the grid does bring with it some security issues, and we need to be aware of those. The improved efficiency of processes, so smart systems that can monitor and control things in real time, take account of what's actually happening in order to control where the electricity flows to, if you like. Agile systems, a word that we use to describe systems which are adaptable in the future. So if we put them in place now, when things change, when circumstances change, and even some other aspects of the technology change in the future, they can accommodate them. Distributed storage, we've talked about that. The idea that we can store electricity, if storage is a great smoother, if you like, of fluctuations. So if we're concerned with fluctuating generation, like solar, for example, then the distributed storage ought to be near the solar generation. If we're concerned about fluctuating loads, like a big city that uses more energy, perhaps at particular times of day, then we want to put the storage close to the load. Smart transportation, inter-vehicle communication, as well as charging systems, scheduling systems, and of course, from a personal point of view, being at the right place at the right time. And then smart housing and smart communities and cities, which I'm going to talk about more in a moment or two. Just want to briefly mention sort of one aspect of the smart grid impact. Here we have the sort of classic hierarchical grid that we have at present, right, with energy flowing from the center out to the consumer at the edge. But in a smart version, then as the load grows at the consumer edge, say the replacement of a gas cooker, for example, or replacing the old global warming car with an electric car, all right? So as the load grows at the consumer level, then as long as we can provide more storage and generation, say at the community level, local to the consumer, then in fact, the impact further back up the grid is minimized. And that's the sort of development that the smart grid encourages, this idea that by looking at where the generation, where the storage ought to be, we can in fact minimize the impact on on the grid infrastructure of this major increase in our electricity use. Now, I want to move on to look at smart communities, how we might manage the diverse and changing energy demands at this level, transport, industry, commerce, living, and social and educational activities. Now, to do this, we need to understand the existing and changing load profile of the community, how it varies from hour to hour, from day to day, from weekday to weekend, from season to season, how flexible those patterns are. Can we change them? What about the demands from industry and commerce that are located in the community? And how are these patterns likely to change over the next few years with the electrification of transport and progressive decarbonisation of the ways that we live and make things, manufacture things? And once we know what our needs are, we need to explore how we might accommodate them locally. What is available and what potential is there? Is there a decent capacity grid connection available locally? Are there local resources that are underutilized? Can we control the load to make it better fit what we have? Can we change its profile? And are there potential new renewable generation sources we ought to explore? Things like wind and solar and hydro or tidal that might be available locally. And of course, is there potential for local storage? Now, transport is a key community issue that needs to be explored. I live in a relatively quiet residential street that's less than 10 minutes walk from the centre of town. Now at 8 in the morning, it fills up with parked cars or parked global warmers, as I'm inclined to describe them, people who work in town seeking free parking. Now, in fact, In New Zealand, more than a third of all light passenger vehicles, these are cars, SUVs, utes, vans, they're driven to work. More than a third of them are driven to work every day and are parked for most of the day. But by 2035, we plan to have cut our transport emissions by 50%. So by then, half of these cars will either not be there or they'll be electric. We need to recognise the significance of some of these changes and how quickly they need to happen. Well, because the sun shines during the day, it makes good sense to charge cars from the sun. So workplace charging, where at least a third of our cars are during the day, makes great sense. And a standard carport-sized roof can easily provide an average day's charging needs for a car. And because solar panels have become so cheap, we don't even need to bother connecting these solar workplace chargers to the grid. They either get used or not during the day, and there may be no infrastructure cost implications or cost at all. So those cars that are parked in my street, by 2035, I hope they'll either have panels on their roofs or their employers will be providing workplace chargers for them. Now, a further point here is the notion of what we call vehicle-to-grid systems, where electric vehicles that are not in use are connected to the grid and can provide storage on the grid, distributed batteries, if you like. Now, our light passenger vehicles, those are the cars, the utes, the vans, etc., they're typically in use less than 4% of the time. This is data from NZTA. My research team's done a study of this technology, which showed that with 40% of New Zealand's light passenger vehicle fleet electrified and using vehicle-to-grid, there could be effectively no cost in charging them, because the storage offered by that vehicle-to-grid system would allow a much larger proportion of the energy from our existing wind farms to be effectively utilised. Current utilisation is down at around 30% for wind farms because of the unpredictability of the wind. Now, I also want to mention the case of community industry. I'm part of a research group recently awarded a contract to explore the electrification of industrial process heat. And a dairy factory would be the classic example. There are many dairy factory towns scattered across New Zealand, particularly around the Waikato, where I live. And in order to sort of proceed with the electrification of that process heat, the factory process itself needs to be electrified. And along with this, there'll be other changes taking place within the community. Things like electric cars, for example, electric school buses, a move away from carbon heat sources in the home. And the factory itself will have a fleet of milk tankers that we hope will be changed to be electric tankers as well. So how can we bring all of these together, the electrification and improved efficiency, right across the entire community, not just considering the factory on its own? Are there opportunities for local generation and storage? How big's the factory roof, for example, and what solar generation could it provide? Is there opportunity for thermal storage in the process itself? And we believe that in the dairy factories, there is the opportunity to store energy in a thermal way within the process, but also the integration of the factory with the community, the trade-off between the profiles, if you like, of energy use with the community and the profile of energy use within the factory. There's a lot that can be gained there. Now, I want to move on to talk about smart homes. Now, most smart home descriptions that we see focus on controlling things: heat, security, making the morning cup of coffee, and providing information like, Alexa, is the cat inside? Now, much of this enabling technology is here. The Internet of Things, for example, smart appliances, voice control systems like Alexa, reliable, high-speed, ever-present communication facilities like 5G. But we need to make effective use of this technology to help us do things more efficiently and to maintain and improve our health, comfort, and quality of life. And from the energy use perspective, better match our demands to the available energy and more integration at the community level for greater efficiency and better infrastructure planning So this is where we get on, if you like, to the building industry potentially, but also looking at the importance of not just looking at an individual house, but looking at that individual house within its community. Now, there are a host of available products that can help us more efficiently, individually and collectively. So there's things like insulation for walls, ceilings, floors, and double glazing. Lots have talked about those up till now. Heat pumps to control temperature more efficiently, new lighting technology, providing the same light from much less energy than our old incandescents, and appliances that do the same job as the old with much less energy, like inverter fridges, European vacuum cleaners, which are required to consume no more than 900 watts, smart water heating as well, that learns your usage patterns and makes sure you have enough water at the right temperature when you need it, and can cut power consumption by around about 20% over a conventional thermostat plus ripple control. Now, I believe that I'm probably getting near the end of my time, so I will just flick through. I mean, all of these slides are available, but I just want to get on to my final slide to make sure that we have my summary. There's an urgent need to decarbonise the 2/3 of our total energy consumption, which is currently not based on electricity. Although some of this may be achieved using energy sources other than electricity, essentially it's going to need a combination of significantly increasing our electricity production, improving the efficiency with which we use it, converting transport and industry to electricity, and that smart grids, associated smart communities and smart homes can provide a pathway to these goals through improved efficiency in use and distribution, and by exploiting new renewable technologies in storage. Well, thank you all, and I apologise for running over time.